Now we start exercise 2.2. Question 1. Find from first principle the derivatives of the following expressions with respect to their respective independent variables. And the first part is ax plus b whole cube. Let us start our solution almost the same way as we discussed or we found our derivatives in exercise 2.1, as we have to find derivatives from first principle or by definition. So we will repeat the same four-step process to find the derivatives of the given expressions of or the given functions. Let y is equal to ax plus b whole cube, and the first step is y plus delta y, and on right hand side x will replace by x plus delta x, so that will become x will replace by x plus delta x, plus b will remain same, and similarly whole cube will remain same. Now delta y will become delta y is equal to ax into a delta x plus b whole cube minus y. Put the value of y, which is ax plus b whole cube, and rewrite this expression in the form of ax plus b plus a delta x. As already we discussed this thing in exercise 2.1, that we have to write a delta x term separately and the expressions which is without delta x separately. So that can be written as ax plus b and the term which contain delta x, which is a delta x. Now delta y is equal to ax plus b, which will become a common to form our binomial theorem or binomial series thing. So that will become 1 plus a delta x over ax plus b whole raised to power cube, or 3 minus ax plus b whole cube. And delta y is equal to ax plus b whole cube and 1 plus a delta x over ax plus b cube minus ax plus b cube. Now ax plus b cube can be taken as a common factor from both of these two terms. So delta y is equal to ax plus b whole cube, and the remaining thing is 1 plus a delta x over ax plus b whole cube minus 1. Now we just open this cube, or by taking symmetry we apply this thing with the help of binomial series formula. So delta y is equal to ax plus b cube 1 plus a delta x over ax plus b whole cube minus 1, and now delta y is equal to ax plus b whole cube and 1 plus nx. Here n is 3 and x is a delta x over ax plus b, plus n into n minus 1, which is 3 into 3 minus 1, 2 factorial a delta x over ax plus b whole square, plus this one is our last term, so that will have a coefficient which is 1. Now a delta x over ax plus b whole cube minus 1. From here we can write it as a coefficient in the form of 3 minus 1, 3 minus 2 divided by 3 factorial, which will become 1. So we will not write this in the form of like this, but this can be noted by yourself, that will become a 1 coefficient of the last term. So delta y is equal to ax plus b whole cube. This plus 1 and minus 1 will be cancelled out, and from the remaining portion we can take a delta x ax plus b as a common factor. So the remaining portion will become 3 from here, plus 3 into 3 minus 1, 2 factorial a delta x over ax plus b, and from here a delta x over ax plus b whole square, because a delta x over ax plus b become a common factor from whole expression. Now dividing both sides by delta x, so delta y divided by delta x is equal to ax plus b, and from here ax plus b, due to the common base power will be combined, so 3 minus 1 and a delta x divided by delta x, and this bracket portion will remain same. So 3 plus 3 into 3 minus 1, 2 factorial a delta x over ax plus b and a delta x over ax plus b whole square. Now delta y over delta x will become a, this delta x will be cancelled out and we have ax plus b whole square. Again this thing will become remain same. Now apply limit delta x approaches to 0, which is our last step of that particular 4-step process. So applying limit on both sides, delta x approaches to 0, delta y by delta x is equal to limit delta x approaches to 0, a into ax plus b whole square, and 3 plus 3 minus 1, 2 factorial a delta x ax plus b and a delta x over ax plus b whole square. The left side will become differentiation formula that can be written as dy by dx, and on right side when we apply limit, all the terms containing delta x will become 0 except this first term. So we have only this 3 and all other terms will become 0. 3 and this thing does not contain a delta x, so that will remain same. So we have finally 3a ax plus b whole square. So the derivative of the given function, which was ax plus b whole cube, is equal to 3a into ax plus b whole square, which is required derivative with the help of by definition or by first principle. And the next part is 2x plus 3 raised to the power 5. Almost the same question, just replace 2 with a and 3 with b. That will become exactly the part 1 of this exercise. Now we start our solution, that y is equal to 2x plus 3 raised to the power 5. Similarly y plus delta y, and on right hand side that will become 2 into x plus delta x plus 3 raised to the power 5. X will replace by x plus delta x, and delta y is equal to 2x plus 2 delta x plus 3 minus y. Just multiply 2 with this x and delta x, putting the value of y as y was 2x plus 3 raised to the power 5, and again rewrite this thing. The term containing delta x will become separately on one side, and the remaining thing will be 2x plus 3. Or just question point of view thing, that you have to form exactly the same thing which is y. So 2x plus 3 here and 2x plus 3 will become here, so that when we take a common thing, that will become a common factor from both of these two terms. Now delta y is equal to 2x plus 3 become a common factor. We have 1 plus 2 delta x divided by 2x plus 3 whole raised to the power 5 minus 2x plus 3 raised to the power 5. Now 2x plus 3 power will be applied on both terms, to 2x plus 3 raised to the power 5, and 1 plus 2 delta x 2x plus 3 raised to the power 5 minus 2x plus 3 raised to the power 5. Now 2x plus 3 and 2x plus 3 can be taken as a common factor. So delta y is equal to 2x plus 3 raised to the power 5 and 1 plus 2 delta x 2x plus 3 raised to the power 5 minus 1. Now we open this expression with the help of binomial theorem. So we have delta y is equal to 2x plus 3 raised to the power 5 1 plus nx. Here n is 5, x is 2 delta x over 2x plus 3 plus 5 into 5 minus 1 2 factorial x square, which is 2 delta x 2x plus 3 whole square, up to so on. As this one is the positive integer, so there must be a last term which is 2 delta x over 2x plus 3 whole raised to the power n. Here n is 5, so that will become the last term, and you must write last term in the case of this positive integer, and at the end this will become a minus 1, which will remain same. Now this plus 1 and minus 1 will be cancelled out, and the remaining portion is 2x plus 3 raised to the power 5, 2 delta x over 2x plus 3, and this thing is the remaining portion after cancelling this one. Now dividing both sides by delta x, delta y over delta x is equal to 2 delta x over 2x plus 3 raised to the power 5 minus 1. Due to the common base, power will be combined, and this one is the division by delta x. and this bracket portion will remain same. Now delta y over delta x, after simplification, this delta x will be cancelled out. 2 into 2x plus 3 raised to the power 4, and this one is again the same thing. Taking limit delta x approaches to 0, applying limit on both sides, delta x approaches to 0, delta y by delta x, and limit delta x approaches to 0, 2 into 2x plus 3 raised to the power 4, and this one is again the same thing. So left side will become dy by dx, and on right hand side the terms containing delta x will become 0 after applying limit. So this will become 0, and all other terms containing delta x will become 0 except this first term, which is 5, and after multiplying 2 into 2x plus 3 raised to the power 4, finally we have the derivative of the required expression, which is 5 into 2, 10, 2x plus 3 raised to the power 4.